Hi guys, in this video we are going to talk about thermodynamics physics again for adiabatic process. Alright, now for adiabatic process we know PV raised to gamma is constant, whereas in case of isothermal process we knew that it was PV is equal to constant. Alright, so in adiabatic change we know system is not surrounded by anything, it's vacuum. Okay, so adiabatic process, that's the reason why if the reaction is exothermic or endothermic, temperature of system rises or falls. Alright, okay. Now in adiabatic change, temperature and internal energy changes. In case of adiabatics, there is no external thing, so it is internal energy which changes. Del U is equal to CV del T, where CV is specific heat at constant volume. Now let's derive the equation for work in adiabatic system. Work we know is PdV, is the formula. Now we have got to integrate from initial volume to final volume. Alright, okay. So PV gamma is equal to constant, so PV gamma is equal to nRT, so P is equal to nRT over V raised to gamma. Fine, so that's what we, instead of P, we substitute over here. Then what do we do? Now rule of integration. Whatever constant comes out of integration, so nRT is taken out of integration and dV over V gamma is there. Now that's what we require. Now it is what? It is C nRT, we take it as constant C. So that's what, instead of nRT we have got C over here, and V initial, volume initial to volume final is our range, and dV over V gamma. Alright, now we know formula for x raised to n dx. It is x raised to n plus 1 divided by n plus 1. Alright, and whatever range is there, that comes over here after this solution. Alright, so here it is 1 over V gamma. 1 over V gamma we can make it in linear form. How? By making it as V raised to minus gamma. Alright, now it gets the linear form. So it would be n plus 1. So here n is minus gamma. So it is minus gamma plus 1. V raised to minus gamma plus 1 divided by n plus 1 minus gamma plus 1 divided by. Alright, and the range which is there, comes over here as the formula. So this is what has happened. Now let's proceed ahead. I bring in two changes. One is V minus I am taking out, so it becomes minus out gamma minus 1. Alright, and this I am writing it as 1 minus gamma and then the value Vi and Vf. Alright, so what it turns out to be now minus, so this would go in reciprocal, and this I am taking it out common 1 minus gamma, so 1 over V gamma minus 1, alright, raised to Vf and Vi. Now this can be C over 1 minus gamma as it is, and here it will take this form first, 1 over Vf gamma minus 1 minus, as per rule, 1 over Vi gamma minus 1. Alright, so we got it till this much. We take C inside, and C is equal to, already we have shown PV gamma. C is constant as PV gamma nRT, right? So this is equal to PV gamma nRT. So this is equal to C that we have taken, right? So we can substitute that instead of C, and C I am taking inside directly. So it is 1 over 1 minus gamma, and it is PV gamma over Vf R minus 1 minus again PV gamma Vi gamma minus 1. Okay, obviously this would be for final, and this would be for initial. Alright, so as mentioned, C is equal to PV gamma, so we take PV gamma inside. Now when it is above final it would be Vf, and when it is above initial it would be Vi raised to gamma, Vf raised to gamma. Alright, Then what do we do is law of indices. VF gamma is as it is. I take this VF gamma minus 1 up. Alright, so as per law of indices, whenever anything comes up, it gets negative sign. So this also gets negative sign. Similarly here also this has come up in the numerator, so it has got negative sign over here. So when we open the bracket, this becomes minus gamma and minus becomes plus 1. Here also when I open this bracket, this becomes minus gamma and this becomes plus 1. Gamma gets cancelled. Alright, so what we are left with is PVF minus PVI. W work is equal to 1 over 1 minus gamma PVF minus PVI. Gamma disappeared, and the same thing can also be written as work is equal to NR 1 minus gamma T1 minus T2. Alright, now as we know, PV gamma is equal to nRT. Alright.